Let's move on to the next question. Two neutron stars are separated by a distance of 1 into 10 to the power 11 meters. And they each have a mass of 1 into 10 to the power 30 kg and a radius of 2 into 10 to the power 5 meters. They are initially at rest, I repeat. As measured from the rest frame, how fast are they moving? Condition 1, if the separation has decreased to one half of its initial value. And condition 2, when they are about to collide with each other. Okay, so this question is taken from Resnick and Halliday, the Principle of Physics book. So this is called something like an ideal thinking question which requires critical thinking. First of all, the author doesn't mention how the condition is, or how the collision gonna be taking place, whether it will be in a straight line, as we assume something in a straight line motion in a kinematics. We assume one dimensional motion, or the second condition would be like the object are colliding in three-dimensional space. So if considering the three-dimensional collision, which is more natural or which can be more likely to happen in reality other than one-dimensional collision, the question will be answered very easily. We just have to find out how the collision will take place. So assuming one neutron star here and one here, they both are revolving at each other, like their center of masses would be somewhere here. Center of mass never change, even though they'll change their position, like this, they'll go in like some kind of elliptical orbit or something like this, but the center of mass wouldn't be changing. It will always be at the same point. So the mass is given 1 into the power 11. No, the distance between them is 1 into 10 to the power 11. Alright, so the actual distance between them is 1 into 10 to the power 11 meter. They have mass of 10 to the power 30 kg. That's a lot of mass, and a radius of supposedly 2 in 10 to the power 5 meter. So how are we gonna solve this problem? If we consider one thing, like consider one neutron star as a frame of your reference, or like you're sitting on one of the neutron star in seeing all the event going on. So what you will do is, what you will see actually is this body is revolving around you. So keeping you as a center, like here, suppose you're standing here, keeping you as a center, we know the distance between you and the midpoint of this neutron star, because in gravitational, or in the Newton laws of gravitation, we assume everything to be a point masses. So density thing won't be there, so we don't have to tackle with density, volume and stuff. It's all about imagining the whole mass is considered, or is concentrated at this point. So the distance we know, 10 to the power 11 meter here, and adding 2 into 10 to the power 5 meter here, which is 2 times, because here again we have a radius of the same radius, so 2 times this, we get something like, let's suppose this thing be y. We got y distance between this center and this center is y. So I'm here, I'm imagining it's going this, everything is moving all around. All right, we are here, standing here, and seeing this object moving around ourselves. So how we know, like how we can calculate force, right? let's calculate the force. We 6.7 10 to the power minus 11, and masses would be 10 to the power 30 the whole square, and distance between is y. We already done with this y square. So this is the force, but the first condition says if their separation has decreased to 1/2 of its initial value, and we are solving a three-dimensional condition. So later on we'll go on one-dimensional condition. So we can calculate the force, but it says 1/2 of its initial value, so we gonna have to take y by 2 the whole square instead of y square according to condition 1. So if we do that, we'll get force. After getting force, this thing is all around going in a circular manner. We are here and this thing is revolving around us in a circular manner, and that's due to which we call as gravitational force, or another name is centripetal force. So centripetal force is given by equation mv square by r, which will be equal to this force which we calculated up here. Here m represents the mass of this neutron star, that is 10 to the power 30, although both are same. Velocity we don't know, we have to find it. R is the total distance, that is y, and f we calculated from here. After substituting y by 2 the whole square and doing the equation getting f, then substituting f here, we can calculate v square here. We'll get something like this much meter per second kind of, and taking under root of that will give us the velocity of that neutron star. So this is first condition, three-dimensional condition. Now coming up to one-dimensional condition, which is actually the collision is taking place in a single line of a single or straight line, in a straight line. Suppose these are two neutron stars, and this is the distance between them, which is 10 to the power 11 meter, and these are the radius, suppose. So what's happening? They'll slowly move towards each other, and it won't be like a constant speed. They'll move something like this. It's like every distance they travel here, they'll have increased acceleration, because force is not constant. Every time the r is changing, so r square would be again a changing factor. So every time the force will multiply or will get squared. So we have to integrate the whole thing by from 0 to half, integrating the acceleration, assuming f x dx, and it will become a definite integral, and by that we can calculate the actual force, because we are here taking a function f x would be an acceleration, integrating that we get a velocity vector. So that would be one-dimensional space, because as like they won't be asking one-dimensional question, because it's more kind of tough and neat, and although won't have a definite integral part into it. So the condition 2 is they're about to collide. When they're about to collide, they are, suppose in a three-dimensional space or in one-dimensional space, both the answer would be 3 into 10 to the power 8 meter per second, because this is this actual speed limit. And when they're about to collide means suppose they have a distance of something like an electron's radius distance, they were about to collide. So at that time they'll be having a speed of 3 into 10 to the power 8 meter per second, because that's this speed limit we have or we know till now. This is the broad question again, because it will again have a deep deep debate regarding the surface, or the surface colliding first rather than colliding the center of that neutron stars. So ये बहुत ही डीप क्वेश्चन है. इसको समझने के लिए वी हैव टू कंसीडर सरफेस. ये सरफेस पहले लड़ेगा कोई दूसरे न्यूट्रॉन स्टार से, एंड डेंसिटी एंड ऑल फैक्टर्स बहुत सारे इंक्लूड होंगे. बट लकीली हमें तो स्पीड लिमिट मालूम है, विच इज़ 3 × 10⁸ मीटर पर सेकेंड. तो जब वो कोलाइड होने वाला रहेगा या 3 डिमेंशनल टाइम पे या 1 डिमेंशनल टाइम पे, उसका स्पीड हैज़ टू बी 3 × 10⁸ मीटर पर सेकेंड. उससे ज़्यादा नहीं हो सकता, और उससे कम तो कोई नहीं बोल सकता. थैंक यू.